Okay, this is lesson 6-1, part 2. And the first thing it says in your notes is a radian measure can be used to find the length of the circular arc. The circular arc is this. So we can use the radian measure to find the angle of the circular arc. And I want you to draw the two blue circles first and label them this angle BOA and DQC. And I want to talk to you about the relationship between these two. I am going to say that this angle is congruent to that angle. They're the same opening, even though that one's bigger than the other, they're the same radian measure. So I'm going to say angle O is congruent to angle Q. So they are congruent, and what that allows me to do is I'm able to set up a proportion between these two blue circles. I can say measure AB, the arc of AB, and the measure of the arc CD are proportional because they have the same central angle, that they're proportional. And I can also say that the radius is proportional also. The radius being OA and QC. If you need to push pause so that you can draw these triangles. But the major point that I'm trying to get out is I'm trying to set up a proportion that the arc AB and the measure of arc CD is going to be directly proportional to OA, the segment OA, and QC. And so they would be equivalent. Now we're going to use this and this bigger triangle that's red and green to help us find the formula that we're about to use. And so I want you to notice that there's the central angle is theta, that's the same, and we have TOR, and then we have WOR, and this should be S. Not sure why that's S. This S stands for something else. This stands for the arc length, this right here. Okay, so let's have a look. We're going to say that the arc length, which is the opening of S, this S right here, over Q, or over theta, is equal to the radius being this whole thing being R over 1. The unit circle in there being 1. So I've set up a proportion. I've done the measure of both arcs like we did on the smaller triangles. I'm going to do this in red to try to hit it home here. Right here we did arc AB. Well, here we're doing arc S. And we're doing over measure of the arc CD. CD was this one, and that's going to be like theta here. So S over theta is equal to the whole length over 1. We're going to use this to take the cross product, and we're going to find that the arc length is equal to R times theta. Okay, that's the formula that we have derived from this picture. We first set a proportion with the blue circles and said that the measure AB over the measure CD is equal to the length of OA, which is the radius, over QC, which is the radius of the other circle. We applied that same concept to this dual circle here, and we're trying to solve for S being the circular arc. So the circular arc is S, and it's equal to R theta. And they say that the arc subtends its central angle. This is the arc, and this is the central angle. And the central angle captures the arc. Okay, so our formula that we just derived is S is equal to R theta. And I want you to know that theta has to be in radians. It has to be in radians for this to work. Okay, let's look at our notes again. It says the length of an arc. The length of any circular arc S, okay, this is the length S, is equal to the product of the measure of the radius times the of the circle and the radian measure of the central angle theta that it subtends, that it catches. So it has to be the S. In other words, this would be theta. This would be your S, which is the arc length. And theta is an angle in radians, and your radius is R. And so the arc is equal to the radius times the angle. Okay, let's look at example 3. Example 3 says, given the central angle of 128 degrees, find the length of its intercepted arc in a circle of the radius 5 centimeters, round to the nearest tenth. I'm going to draw a picture of this real quick. 128 degrees, I would say, would be, I don't know, about that wide. And we want to find the S for that, the intercepted arc, find the length of its intercepted arc, and the radius is 5. Okay, now if you go back and remember, I told you that it has to be in radians. And notice this angle is not in radians. So we are going to have to convert the central angle of 28 degrees to radians. So I want to do 28 degrees over 1. I want degrees to go away, so I want to put it over 180 on the bottom and pi. Okay? And I cancel, and this will go in to this, leaving 45 here and 32 here. So it reduces to 32 pi over 45. Okay, so we have got it in radians. Now we're ready to plug it into our formula and find the arc length. S equals R theta. So we're solving for S. We know the radius is 5, and then we do 32 pi over 45 is our central angle in radians. Okay, if we can cancel or do anything, that would be great. The directions say that you can round to the nearest tenth, so I can do 5 and make that 9, but I'm still going to have to put it in my calculator, and I get 11.17, and when I round that to the nearest tenth, I get 11.7. And this problem was all in centimeters, so this is in centimeters because this radius over here was centimeters. So that is example 3. Just the key in this problem is to change your degrees into radians. This has to be in radians in order to work this problem.